Here's a word problem where we'll use the law of sines to solve it. Let's see, a biologist tracking an animal with radio transmission color detects the animal in a line that is 27.5 degrees off the trail. After moving 155 meters down the trail, the line to the animal is 38.8 degrees off the trail. Assuming the animal hasn't moved, find the distance between the biologist and the animal. So first let's draw the trail. Here's the trail the biologist is on. He or she starts by noticing the animal at a 27.5 degree angle with the trail. So here's our animal here. After the biologist moves 155 meters down the trail, let's say they get to about here, the animal is now 38.8 degrees off the trail. Assuming the animal hasn't moved, find the distance between the biologist and the animal. So let's fill in the pieces that we know and what we want. At this point, this is where the biologist is, so we want to know the distance between the biologist and the animal. We're looking to this side of the triangle. Since we know the 38.8 degrees in this angle here, we know inside the triangle we have 141.2 degrees. And then finally, to get this third angle, we have 180 minus 141.2 minus 27.5, and we get 11.3 degrees inside that triangle. So here, if we want to solve for x, this problem is set up for us to use the law of sines because we have one side and three angles in our triangle. So let's set that up. I have sine of 11.3 degrees over 155 equals sine of 27.5 degrees over x. We're trying to solve for this distance opposite the 27.5 degree angle. Then solving for x, I'll find 155 times sine of 27.5, 5, over sine of 11.3. So we get x, after we calculate, of course, 155 sine of 27.5, and make sure that your calculator is in degrees. We get that the animal is 365.26 meters away from the biologist.